Once you've graphed your system of inequalities and you've found your corners, our next step is to write the equation we want to maximize or minimize. Now, if you recall back from our original situation, we have that our non-stop flights sell for $600 and our two-stop flights sell for $400, assuming that they will be full flights, and we want to maximize our revenue. So going back now here, I want to assume or letting R equal our revenue. That being said, R is going to equal $600 times the total number of packages sold, which, if you recall, total number of packages sold is going to be the number of flights times 150 people per flight. So we have 150x times 600, plus the $400 for the two-stop flight, and each flight carries 100 passengers, so at $400 a pop, we're going to have basically $40,000 times that number of flights. So now that we have our equation, we're going to substitute those coordinates into that equation. So remembering back from our last page, our coordinates are 0, 0, 0, 10, 4, 6, and 8, 0. So substituting those in, we get, for the first one, 600 times 150 times 0 plus 400 times 100 times 0, which clearly is 0 plus 0, so a revenue of $0. If we have 0, 10, we have 600 times 150 times 0 plus 400 times 100 times 10, which the first part is 0. 100 times 10 is 1,000, times 400 is going to be a whopping revenue of 400,000. So I'm going to write 400K to save space. Then if we have 4, 6, that is 600 times 150 times 4 plus 400 times 100 times 6. So that first part, 150 times 4 is 600 times 600, which is 360,000. 100 times 6 is 600, times 400 is 240,000. We add those two together and we get 600,000. Then finally, we see that right now 4, 6 is running in the lead, so let's check 8, 0 to see if it works. So we have 600 times 150 times 8 plus 400 times 100 times 0. Well, obviously the second part equals 0. 150 times 8, you figure 15 times 8, which would be 30 times 4, which is 120, so 1,200 times 6 actually comes out to 720,000. So now our final step is going to be that idea of taking our values and selecting the appropriate result. We want to maximize our revenue. Therefore, we want to pick the largest value, which means that our ordered pair 8, 0 is going to result in the largest revenue. This means that they want to sell 8 non-stop flights and 0 two-stop. Now, I know some of you are probably going, well, we can reserve up to 10 planes, so wouldn't you want two-stop flights to get the maximum number of revenue? You make a valid argument, however, recall that we are using the corners to be those maximizing spots because the ordered pair 8-2 does not fall within our region of our constraints. So now you have to write a summary. There are no you-try problems, but we will finish up the problem that we started in class yesterday during the POD tomorrow.